his reasoning and his ability to solve problems is at a higher level. So I thought that was an interesting concept of like, okay, how do you define intelligence? Because these systems are trained on the entire corpus of the internet where
Right.
they know everything. And so seems like they're intelligent, but are they actually intelligent? Can they solve problems given very limited context about the problem? Welcome to Tech Talks AI. Today we're going to be doing our first episode, Intelligence at Scale. I'm Dallen Pyra. I'm here with Tristan Johns. I'll give a quick introduction as to who we are and what we do at In Time Tech, and then we'll go ahead and jump into the podcast. So I'm Dallen Pyra. I've been here for the last 4.5 years. I graduated from boot camp before I came to In Time Tech, and I've been interested in software for a very long time. When I was younger, I didn't realize that I was doing scripting until I kind of got into software later in my life, trying to build out video games while I was at school so that I didn't have to play them because you have to progress in the game while playing it. So I just had bots do it. So that's kind of how I got into it and then kind of became more professional, going to boot camp and working here at In Time Tech. And so I've been on a few different projects in Time Tech, doing back-end engineering, front-end engineering, full stack engineering, and recently getting into helping companies build out their workflows with AI, building up their engineering teams to start using tools like Cloud Code, Warp, AMP, things like that, so that they can be more efficient. And so that's who I am. I've been working hard to understand where the landscape is, and what we're here to do today is kind of take what we've done internally with our workshop course that we do for internal engineers in In-Time Tech and bring it out to people in the world who are interested in learning more about AI. So that's me. We'll pass it over to Tristan to give his introduction.
Thanks, Dallen. I'm Tristan Johns. I had a pretty similar journey as Dallen here. Um, I've always been a computer kid growing up. I got into a few different scripting languages. Like I realized about .bat files and languages like AutoHotkey. So I guess my interest with programming was always about what I could do with the computer, and that kind of brought me towards the software engineering career as well. I went through the same Boise CodeWorks boot camp that Dallen mentioned, um, and before that, I studied philosophy, and that's where really a lot of my interest in AI first started. Was considering like where could AI actually go in my lifetime, because at that point it wasn't really a hot topic, but it's exploded, and now I use it every day for research and coding assistance and a lot of different activities. So I'm excited to talk about intelligence at scale today.
Yeah, I think it's something that everyone's interested in is AI at this point, whether or not you're scared of it or you're excited, or maybe you're a little bit of both. But I think today we'll kind of jump in like what is intelligence in general? Well, artificial intelligence, but also intelligence with humans and what intelligence means. And so what I want to kind of jump into is what our definitions of intelligence is. And so I'll ask you, Tristan, first. What's your baseline for how you identify intelligence?
Yeah. I think there's a lot of different varieties of intelligence, but if we look at it generally, I think you could relate intelligence to something like efficiency. So if I see a bird and it's trying to open this nut and it's like picked up this nut in its beak and it's smacking it at the ground, I can tell it has some kind of intelligence. It has a goal and it's reasoning about how to get into that nut. But then if I saw another bird and instead of like hitting it at the ground, the bird flew up on top of an intersection, like a four-way intersection, and it drops the nut in the traffic and cars drive over it, and then it picks up the net, I would say that that bird is more intelligent than the other bird. It's identified some way to accomplish its goal more efficiently.
Okay. How how do you identify even more intelligent beings? Like there's different levels of intelligence in birds, and then there's different levels of intelligence in monkeys and then
Mm-hmm.
humans. And I think we'll see the same thing in AI systems.
Mm-hmm.
And so maybe where do you think our systems are right now in terms of intelligence?
That's a really interesting question. Um, I think we are at the point where it's hard to actually gauge intelligence. Like that's how intelligent they are. Um, if you if you just talk to them, I feel like that's a really good way to gauge intelligence, just as you would talk to any other human being. Um, you have a conversation and see the responses they give, and then fact check it. And I feel like that's honestly one of the best ways.
Hmm. Yeah, that's almost like your first introduction to like social intelligence, how these models kind
Mm-hmm.
of behave while they're talking to us and such.
Mm-hmm.
I think my definition of intelligence has changed. I recently listened to a podcast on some ML researcher, and he kind of has some gripes with where the models are currently and how people are defining AGI,
Mm.
because his definition of intelligence is um, beings or machines that are able to do and complete tasks with minimal context or minimal knowledge about the task that they're trying to complete.
Hmm.
So he kind of gave the analogy of like, who do you think's more intelligent? Someone who's been studying all week on the specific problem that you're trying to solve, and he comes and helps you solve the problem that you've been stuck on for a week, or the guy who's been, out at a pub for a week, not studying the problem, and he's just able to come in an hour and fix your problem.
Mm-hmm.
Um, One is more knowledgeable about the subject, so he understands how to fix the problem. One just maybe more intelligent,
Yeah.
and his reasoning and his ability to solve problems is at a higher level. So I thought that was an interesting concept of like, okay, how do you define intelligence? Because these systems are trained on the entire corpus of the internet, where
Right.
they know everything, and so it seems like they're intelligent, but are they actually intelligent? Can they solve problems
Mm-hmm.
given very limited context about the problem? So
I really like that example. Um, the guy who studied versus the guy who didn't study. And I'm almost comparing it back to what I was exploring with the bird example. So if you had this intelligent bird that figured out, oh, if I drop this nut in traffic, it'll open. Um, maybe you have another bird that saw that bird do that, and then it copied that behavior. Maybe that's not intelligence, but that's knowledge.
mm,
Like so, the bird, the first bird to reason about it and discover that, that's an act of intelligence.
mm.
That is interesting. Yeah, there's something like there's a new generation of information or a discovery or something.
Yeah, and I think information can make us more intelligent, and it makes us seem like we're able to solve more problems because we have more knowledge. But I haven't seen any model be able to do what a lot of the scientists like Einstein and his inventions, or Nikola
Mm,
Tesla and his inventions. Like we've not gotten to the level of artificial intelligence curing anything yet, or necessarily coming up with new math or anything like that. Maybe we will in the next year or two. But I think we're we're getting close, but we're not quite there.
I think we've seen some examples of AI inventing new math,
Hmm.
and maybe it's debatable with like how much human involvement there was there. Um, and I would need to research that more, but we're definitely getting close. Um, but I would like to back up a little bit. Um, Recently, you mentioned AGI, and we've been discussing AI and what intelligence really means. So I just wanted to define AGI for the listeners. That stands for Artificial General Intelligence. And that is moving closer to AI less as a tool or like a computer that does tasks and more of a fully functional worker, kind of like you were saying with being able to have limited context and still get the job done.
And I think another term we can define there is ASI,
Mm-hmm.
artificial super intelligence.
Mm-hmm.
I don't know if any labs have claimed they've reached AGI yet, um, but I know the next step after AGI is ASI, and and, and that one is um, that's when supposedly the models are become smarter than any human on Earth at everything.
Mm-hmm.
And so that's super interesting. I don't know when that will happen. I don't know if we've reached AGI, but I think those are two good terms to define for the audience.
Yeah, yeah, especially when considering intelligence at scale, because I feel like that's a good way to think about it. Like we have AI as we are scaling, but it's still in the introduction or early stages of scaling. And then AGI is like in the middle of scaling. And then ASI is what does this look like in the far future,
Hmm.
possibly when AI is scaling itself, like AI is doing AI research.
Yeah, I think maybe we could get more into like the aspect of intelligence at scale, because I think a majority of us, we interact with models, Claude, GPT-5, um, but there's a ton of models out there of varying sizes and capabilities, and you can get super niche on what you use each model for. And uh, I don't know if everyone understands like how do you get to GPT-5 versus what GPT 3.5 was,
Mm-hmm.
and what it means to um, scale intelligence. And so maybe we can discuss how varying models have varying sizes and capabilities, and what they're able to do and be deployed where. So maybe first thing we can kind of get into is uh, just how large something like GPT-5 is, or like Claude 4, and defining that for the audience. And so I don't have like exact numbers, but I know it could be in the trillions of parameters of how large these models are and what are parameters. It's basically the data that it was trained on. And so it could be the entire internet plus the entirety of every library you've ever been into, every book, every page, every Reddit forum, every YouTube video. It's trained on, and
Mm-hmm.
and that's essentially like where we're getting to with these large models. But I know something like Quen, they have 7 billion parameter models, 32 billion parameter models, and they seem just as capable as GPT-5 until you get to that level of complexity where you need something like GPT-5.
Mm-hmm.
And so maybe you can help us define, like, I don't know if you've played around with these smaller models much, or if you've kind of been focused on these um, higher level models.
Yeah, yeah. I definitely recently have focused more on the larger models, just because I feel like that's where we really start to see intelligence. Um, but there is use cases for smaller models and scaling it down and deciding how much you really need for each job. Um,
What are those use cases?
well, you can look at your goal. So if your job is to support customers, you might need a less intelligent model than, say, if you're doing chemical research. So you can tailor the model size to your application or your use case. But I'd also like to explore the other maybe dimensions of scale in an AI. You make a really good point about the parameters. That is one of the main ways to measure these different models, I feel like. But it is also kind of abstract. It's like parameter is kind of an engineering term, so maybe not everyone understands it. But to give a little more context, like these bigger models, even though they are non-physical in nature, they still are physical somewhere. So there's warehouses full of computers, and these computers are they have electricity running through them, and that's how we're actually getting these inputs and outputs. So that's where a lot of the cost can come from scaling these models. Is it's not just that it takes a lot of money to train them, but it also takes a lot of money to host them as well.
Yeah, a lot of resources, a lot of, I mean, takes an army of people,
Yeah, yeah.
honestly.
hmm
I think a good case study is like what XAI did in how they've reached frontier level intelligence in, I don't know, like 4 years, 5 years. OpenAI has been around for a while. Anthropic's been around, Google,
hmm
where XAI, I know they built one of those data centers where their models are hosted in maybe like 6 months. Like I know it was under a year. And at first they were pulling in generators
Yeah.
from different parts of the United States because they didn't have the power supply set up yet. So they were supplying the data center with generator power.
hmm
And really, uh, in order to get there, you need someone who's able to build those data centers, build a team that's able to train these models. You have to have infrastructure, like
hmm
engineers who are able to take what the models are able to do and build websites and applications. And you need people that are looking at the data centers, making sure they're up and stable and secure. Like AI is at scale
Yeah.
is, I mean, it creates a lot of jobs, but also, it takes a lot
It's a
to
big
keep them
investment.
running. Yep.
Yeah. And the model doesn't really care how you use it. So if it costs billions of dollars to set up and maybe your prompt cost $10 overall and you were just asking like what's the weather right now? Like there are different use cases that are better fit for that level of investment. Yeah.
Yeah, but I mean, there are some models you can run on your Mac,
Yeah. Yeah, or your phone.
your phone.
We're getting really small models.
Yeah.
That's true.
I know there was a recent podcast, Matthew McConaughey was kind of, he wanted intelligence on his Mac that didn't give him answers about other people's intentions and what they want to do. He just wants to train it on what he wants to do
Nice.
and the answers that he wants to get on his data. And what I thought was funny is like, we already have that.
Mm.
We already have the ability to do that and run these models on our Mac. I know I've been running a model on my Mac for autocomplete in my code IDE, um, integrated development environment. For those who don't know, that's we can't necessarily use something like Cursor in our project.
Mm.
And so what we've done is taken super small model. It's like 3 billion parameters, 7 billion parameters. It only takes a few gigabytes of RAM to actually run. And it's able to give me the autocomplete that I need in my IDE while being safe, secure, local. I can turn off Wi-Fi and it still
Yeah.
works. Like, I think there's definitely use cases for those smaller models. And I think we'll start seeing more highly capable small models in the next couple of years.
I really hope so. I think there's a few different risks that come with AI, but I feel like some of the risks, like privacy, can be resolved with local open source models. Um, and I'm curious to see how that will unfold. It kind of seems like a lot of the large AI labs really have the resources to hire these really expensive engineers and make that much progress, but I am hopeful of the open source community.
And I think in America, we need to get better at doing open source models. I know a lot of the open source models are coming from overseas.
hmm
Um, Recent ones in the US have been like GPT. I think they made like a 120 billion parameter model and then maybe like a 32. And then they're open sourcing Grok 2 and Grok 3. But there's really no labs that are like building open source models for everyone to use here. I feel
Mm,
like it's more we're going to build frontier models, trying to make as much money as possible. Whereas overseas, I'm seeing a lot of Quen releases,
hmm
DeepSeek, Kimi K2 is another model, which is giving back to the community. I think in a sense, I love when open source models drop, and uh, I have the option to run them locally, and I don't have to pay anyone to actually use them. Now I don't have a large enough machine to actually run
Mm-hmm.
a lot of those locally, but if I wanted to, I could. And I
Mm-hmm.
think that's a big thing to look at is um, when are we going to be able to get something maybe like GPT-4 level that's able to run locally on our MacBook? I don't know if there is something out there currently, but I think a GPT-4 level open source model that can run on our Mac can do a lot of things for people and keep things safe, secure, private. And you could even use it on a plane with no Wi-Fi.
Yeah. Yeah. I don't yet have a machine that can run any of these more intelligent models locally, but I am paying attention to the scene a little bit, and I'm curious if you've identified any research labs that are particularly interesting to you,
Hmm.
or
I, I think DeepSeek with what they did was pretty uh, pretty crazy.
mm-hmm.
They kind of came out of the blue, dropped DeepSeek R1. And I think I mean, it was around the time when O1, uh,
Yeah,
OpenAI O1 came out. It was like the first reasoning model,
yeah, exactly.
but they didn't, I don't know if they had allowed people to see the reasoning traces yet, but they might have. But I know that DeepSeek R1,
Mm-hmm.
they allowed you to see the reasoning traces, and the way in which they trained the models was pretty unique because they're constraints. So I would have to say DeepSeek has probably been, my favorite lab in
Mm-hmm.
terms of like what they're able to do with their limited resources. They're not able to get the GPUs that big labs in America are able to get.
Yeah.
So they had to get more efficiency gains out of their existing GPUs. And so in order to do that, they needed to go lower and lower into the tech stack. And so they're getting closer and closer to assembly, where some of the big labs are using something like Python, which is really easy to code in, but not necessarily super efficient.
Right.
And so I, that's probably, my favorite lab at this point. And on the US side, Anthropic, I really like what
Mm-hmm.
they're doing in terms of like their branding and how they're kind of shaping what their AI is able to do. They had a recent advertisement that kind of went out where uh, it focused on problems and how their mission is to help us solve problems, but for us to keep thinking. It's
Mm.
not about having AI replace us.
Mm-hmm.
Uh, we'll still need to think, but it's kind of an extension to help us solve all of the problems that we may encounter in our
Yeah.
life, which I think is great. Like, I want to see that type of commitment to humans and
Mm-hmm.
kind of helping us extend our abilities rather than replace us entirely. So, those are my two. Um,
Yeah.
what about you?
Yeah. There's a lot to dig into there. I think for the research labs, one of the main ones that I keep seeing is called New Research, or it's maybe Nous, Nous Research.
Mm.
They'll release these Hermes models, and recently they released a Hermes 4.
Mm.
And it's their it seems like their philosophy is almost the opposite of what DeepSeek's was with some of the censorship and things we see from DeepSeek. They try to release their models as more like steerable and more open, I guess you'd say. Um, but yeah, there's a lot of different companies that are trying to build models right now, and it does seem like the cost of investment means that some of the larger corporations are best set up to build. If I remember correctly, I think DeepSeek was like they said their company was profitable enough already that they didn't need to sell it or
Hmm.
something like that. They were like a trading company.
Yeah, they do. They're a bunch of quant traders.
Right.
So the talent there, I think, is ridiculous. And
Mm-hmm.
so they took their talent from whatever they were doing there and built out
Mm-hmm.
DeepSeek. So they don't really need DeepSeek to be profitable, which I
Yeah.
think is cool.
Yeah. I'd like to get back a little bit to scaling, if we can.
Yeah.
Are you familiar with dot products?
No.
So I'm not an expert or a theoretical machine learning person, but I've been learning about dot products recently. And dot products are used, it seems, a lot throughout the training process, as well as in our own biology and like our neurons and our brains as well. But a dot product is relatively simple. It's a simple concept by itself. There's multiple inputs, and you weight and you sum them, and you get one output. And that by itself doesn't seem very impressive, but what's impressive is when you scale that process and you do that millions of times. That's when you start to get these emergent properties like intelligence. Um, and I just feel like it's a really good example of how we might not fully understand how to build these things, but once you scale them, like you give it more
Mhm.
compute and more data, things start performing better.
Yeah, I mean, it's really similar to how we as humans gain intelligence. I
Mm-hmm.
mean, the more and more things we experience and
Mm-hmm.
learn, the more and more capabilities we have. But I think it's a different scale with AI. Um,
Yeah.
it's I think there's more emergence with AI than with humans. I think we can kind of understand our capabilities, what we can and can't do, where because of how we may not understand how these models perform, the more and
Mm-hmm.
more data we give them, the more and more scale they get, I think uh, we may not fully understand their capabilities like entirely.
Yeah. 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 It's one thing to say that like the things that the machine learning is doing is similar to our brains, but it's still alien. Like
Yeah.
it's still a vastly different system. Um,
Makes me wonder if we spend more time researching the brain. Maybe what AI can unlock is our ability to understand uh, our own anatomy so that we can take what we've done, whatever is happening here, into those systems.
I like that you make that point because sometimes I feel like we are rushing AI a bit. Um, there's something in philosophy called the hard problem of consciousness, and essentially it's like I can talk to you, we can have a conversation, so that we both feel like we have some kind of mental model going on in my head, but I can't actually go into your head
Hmm.
and verify that you can see me or actually understand like what we're talking about. Like there's a hard problem.
Yeah.
And that also applies to AI as well. So if it gives me an answer, that's great. The answer might work for my solution, but I don't know if if it has the same experience of the world as I do,
Hmm.
or it's like I can't validate all of the same ways that it thinks.
Yeah, there's no way for you to reach into what I'm thinking, vice versa, and
Mm-hmm.
then same with a model.
Yeah.
Yeah, that's tough because I know there's people out there who are trying to understand and trace how
Mm-hmm.
models get to certain outputs,
Mm-hmm.
but it's an incredibly hard thing to do.
Mm-hmm.
Um, and so I don't know if they'll ever get there. I have faith, but I think it'd be really cool if we could understand uh, how models get there.
Mm-hmm.
Because I also think it's like a safety thing. Because how do we know that it's aligned
Absolutely.
with us?
Yeah. Absolutely. I think reasoning traces are helping where we can kind of see some of its thinking before it gives the output. But even then, you have to kind of analyze it and say, okay, what is its real intention here? Like, is there a hidden intention? Um, Especially as we have these longer and longer context windows, it could be that this AI hides its intention
Mm.
until it's actually ready to do something that we don't expect or want.
Yeah, and it's I'd like to ask you something about what your idea or how you feel about models in training them to think in their own language.
Mm,
Because currently they think in a language that we understand, but I've seen that there could be more efficiency gains, and uh, the capabilities in the models could grow even faster if we allowed them to come up with their own language that was more efficient than something like English. But what I've seen is people saying, that could lead to us not fully understanding what they're thinking, uh, how whether or not they're aligned with us or if they're aligned with their own self interests. Whereas if we keep scaling with English, at least we're able to see its reasoning traces, its outputs, and see at least a little bit of kind of like what it's thinking. Whereas if it has its own language, how do we know?
yeah, I have a few thoughts here. Um, I believe we've seen something like that happen already, where I forget the exact scenario, but I believe researchers had two AIs talk to each other, and after a long enough time, they started developing their own
Mm.
language. So I believe that's totally possible. Um, and I think there is some valid concern in them having their own language, but at the same time, I'm I'm kind of thinking that if we scale intelligence to a certain point, they could use English and talk to each other, and still also we don't even realize what they were talking about.
Yeah, they could maybe come up with hidden meanings
Yeah,
in the English,
in the English.
maybe even uh, patterns in what they're saying, like one letter patterns in
Mm-hmm.
each word.
Yep, or
Yeah.
spaces, or it could be there's really like infinite,
Yeah.
near infinite.
Invisible characters.
So I guess I'm saying, yeah, let's explore them having their own language, and
Yeah.
then come back and tell us like, hey, are you honest? Do you have best intentions here? Yeah, I think this almost gets back to like, how do we validate that the work was good, um, or if it's true. And I really feel like as AI becomes more intelligent, a lot of people are saying like, oh, we won't have to think as much or something like that. But I think it really brings philosophy and critical thinking back to the forefront,
Hmm.
because we can't just assume the answer is correct, or that they're they are aligned. We can't just assume that.
Yeah.
So,
Yeah. How do we know they want our self interests
mm-hmm.
and they want us around?
Yeah.
it I'm like on the fence about whether or not allowing them to speak in their own language is a good thing.
Mm-hmm.
Um, you could definitely get more capable models, more efficient models that way. Um, but I was recently watching a video on how that can that can we're not at the level of like traceability yet where allowing them to do that uh, is safe. Like I could see maybe in the next 10 years, like 10 years from now, 5 years from now, allowing them to do that. But maybe if we were to do it right now, we still need like our development tools to reach a level where even if we did allow them to speak in their own language, we need to be able to decode kind of what they're doing because we're not even able to decode what they're doing in English yet. Um, and I think that's scary in a sense because if we can't understand what's going on in someone's head, we need a level of trust.
Mm-hmm.
And I trust you, but do I trust a model? It's not human. There's not that level of trust between a model and a human yet, and so I think
Mm-hmm.
that's really important. Um, but I'm like an AI optimist,
Mm-hmm.
but even that scares me in a
Yeah.
sense.
Yeah. Yeah. I definitely think it's important to be optimistic, but also aware of the risks. Um,
Definitely.
I'm also thinking that it's possible there is a middle ground. Um, so, for example, computers speak in binary. We can't really read binary efficiently. So we had like machine language, and then we created syntax. So those are ultimately ways to get the human better talking with the computer. So maybe there's like a middle ground where they create their language and we create a language on top of that to
Mm.
like bridge English and theirs or something like that.
Some decoder in the middle,
Yeah.
translator.
Yeah.
I think that'd be good. That that would definitely curb my fears.
Yeah. You do need some kind of traceability
Yeah.
or yeah, auditing.
Yeah, I think uh, recently labs have been more focused on efficiency. I don't know if everyone knows about scaling laws. I think that'd be a good thing to cover in terms of like
Yeah.
intelligence at scale, because there's um, there's currently a widely known fact in the community that there's scaling laws in place in terms of you can get a more performant model uh, based on the amount of compute and data that
Mhm.
you're able to give it. And so currently, I think people are kind of focused on getting more and more compute, because that
Mhm.
means you like in the math, it shows that if you get more compute, the scaling laws show that you can get a more capable model.
Mhm.
Um, and I think that's really interesting that there's already like limitations
Mm.
there. Like there's natural universal limitations that we don't quite understand, um, but we know that they're there, and but we also know how to get past them, but we don't know how to break out of that scaling law.
Mm.
Like we don't know how to go from like just a straight line to exponential,
Right.
which I think is super interesting.
That is really interesting. Do you know if we have a name for that scaling law yet? Okay, because I wanted to give
Yeah.
more context. Even before that scaling law, computers, there's been a well-known scaling law called Moore's law, and that's more applied to transistors than AI. So it's like lower level in the hardware, and essentially, in layman terms, we're able to fit more and more transistors in a smaller space, and that's allowed us to scale our hardware um, so much. So we're seeing scaling laws in a few different places, and it is interesting that there might be an upper limit, and maybe we could break through that. But
Yeah, I want to understand how we can get the models to understand why there's scaling laws in the first place.
hmm
Because we didn't invent scaling laws. That's just something like ingrained into
like physics, I suppose.
physics.
Yeah.
Yeah. Which is like I would love if we could understand more around
hmm
that. Because we know it exists, but may not know why.
hmm Yeah. I guess something the listener could think of is like, does efficiency always matter more to you as a user, like faster, cheaper, and smaller? Or do you always want raw capability, the most intelligent, like at the very forefront of that scaling, but it costs more?
What would you say?
I think it depends. Um, if I'm if I'm asking it something like, what's the capital of Maine or something, it's like a smaller model would probably be better. Um,
You don't want something thinking for 10 minutes,
I don't. Yeah,
Yeah.
exactly. Yeah. But if I'm learning about something I don't know, like dot products, then I'm absolutely going to talk to GPT-5 or whatever the most uh, current model is.
It seems like maybe the complexity of the problem correlates to the level of quickness you want from a model.
Absolutely. Yeah. Whereas maybe I'm building a video game and I want it to be like an NPC that has its own large language model and can talk. I don't want that to be expensive. I don't want that to be slow. I want that fast and cheap. So both use cases are valid, but we all have different goals that we want to accomplish.
Yeah, I think I could share like what I use for different varying levels of when I need intelligence. Like if I just need a quick answer, I'll use Perplexity.
Mm-hmm.
I think that's pretty good, getting up to date information, but also their models. I mean, they're using some stuff like GPT-5 and Claude, um, where if I need something in depth, a lot of the times what I'm doing is coding. And a lot of the times what I need is information that the model doesn't have. And so I'll go and I'll use GPT-5 high, turn intelligence and reasoning to the max. I'll give it tools and I'm okay. Like if it takes 3 days for that model to go and um, implement something, I'm okay with that since it's something that's so complex that uh, if it were something that I would do, it might take even longer than that. And so something like that, I'm okay if it takes a long time. I don't need it instantly because the problem that it's solving is more important to me than the time that it takes.
Mm-hmm.
And I think maybe that's what people can think about is what problem are you solving, and are you okay with that problem taking 3 days, or are you okay with that problem being solved in 10 seconds?
Mm-hmm.
And I don't necessarily know if the model can solve all people's problems in 10 seconds. And so uh, I think having varying levels of intelligence at scale,
Mm-hmm.
large, small, medium, is important.
Yeah, absolutely. And it really highlights that importance of like having awareness of how much a token costs. Like it's a new dimension that business people can look at. Like, what are all the different models out there? Yeah.
And token cost, I've seen people. One of my arguments that I don't really argue with people, but one of my arguments is uh, we should align token costs like
Mm.
with electricity, like how we bill
Oh wow.
electricity, because um, I mean, in some states, electricity's more than other states because of whatever constraints they have, their power grid, whether or not they have clean, sustainable energy.
Mm-hmm.
And I think that kind of correlates back to models where someone like Cursor right now, um, I honestly think they're bleeding cash. I don't think
Mm.
they're profitable
Mm-hmm.
because they're giving people subscriptions at $20 a month. And these people are able to use these models however they see fit. And there's usage limits there, but I don't think they're profiting off their $20 a month.
Mm-hmm.
Where what I see being more profitable to companies is something like what Klein is doing. Have you ever heard of Klein? Or
I don't think so.
so Klein is like Cursor, but they build the infrastructure, they build the tool. You bring your API keys.
Yeah.
You pay for the cost, which is generally like electricity, in a sense, where the more you use it, the more it costs. And I think that's more sustainable,
Mm-hmm.
and allows for people to kind of choose. Okay, I need a more expensive model here. I need a less expensive model here.
Yeah.
But my kind of argument is, I think companies that are charging subscriptions right now, they're either gonna fail out unless these models get cheaper,
Mm-hmm.
or they're going to switch to something more sustainable.
Yeah.
I think there's just so much money being pumped into the companies right now. They're able to do that, but I don't think they're able to do that forever.
I would probably agree with your intuition that a lot of these subscription based platforms aren't very profitable. Um, Crap, I just forgot what I was gonna say. Um, oh, okay. So, from a business side of things, I feel like paying a subscription is a lot more approachable to a standard user,
Hmm.
like someone that just wants to build a little app. Whereas the client approach, that's definitely more supportive for engineers or people who are comfortable with that. So I definitely see that that's a more sustainable business model. You provide the infrastructure, the user pays for the tokens. Um, I really like what you said about the electricity peg, I guess you might call it. We do need some kind of standard. With Amazon's agentic IDE Kuro, they use credits, whereas you look at a different platform, they might use something else. So it's hard for the user switching between a lot of different models to have an understanding of like what am I actually using here? How much do I actually have left?
Hmm.
And with that said, it is almost comparable to electricity. Like I've heard people say this is like a new form of electricity, or I think the CEO of Google said this is a AI is a bigger deal than fire, like discovering fire. Um, so we do need some kind of standard, a way to measure that uniformly.
Yeah, I really believe the direction is this is kind of my idea for what I'm going to do for charging for the app that I'm building.
Mm-hmm.
Uh, Subscription based, but that subscription includes usage. And so maybe it's like $20 a month.
Mm-hmm.
You have $10, $15 in usage. That usage is directly correlated in the chats. So in the chat, you can see how much have I used in this chat session.
Mm-hmm.
You can go to the dashboard. You can see how much usage do you have left. It's not credits.
Mm-hmm.
It's just dollars. You can see it. It's not abstract. It's really
Yeah.
easy to understand. But then also allowing users to add more usage, not restricting them to whatever their subscription
Yeah.
allows. I think there needs to be some sort of, okay, we have this subscription because we built this platform and we put a lot of work into it, and because we put that work into it, like the people that are working on it need to be paid. But also I think there needs to be due diligence on the people that use the platform. They expect a level of quality, and I think if we do it usage based, that quality can stick around much longer than if you do something like Cursor, where uh, they may try to optimize costs
Mm.
in a sense, and optimizing costs doesn't always lead to the most performant system.
Absolutely.
And I think, what I kind of align with is let's build the most performant system, um, give it to people at a cheap cost. But if they want to use it more, then their subscription allow them to buy more usage.
Yeah.
And I think that's more sustainable in a sense, and more pegged to electricity and how we bill
Yeah.
for electricity.
Yeah. I think that's a great approach. Yeah. I think ultimately it comes back to showing it to the user in a way they can understand.
Yeah.
Yeah.
So I guess what have people learned about intelligence at scale today? I would say systems are trained on loads of information. They're emergent. They have capabilities we may not fully understand. We're not able to 100% trace their thoughts, but they're also incredibly capable and help us solve problems that we were unable to solve previously, or maybe unable to solve in a certain amount of time previously.
Mm-hmm.
I think intelligence at scale, it's only going to get bigger. We're only going to get more data centers, more models. So I think it's an important conversation to have. Um, what have you learned in sort of researching this topic that you can kind of share with the audience?
I've learned there's a lot of factors going into it. Um, I've learned to be flexible. I think it's important to um, stay current with all of the different changes that are happening. And really, that just reinforces staying flexible. Like you want to learn, keep learning. Yeah.
Kind of that openness mindset,
Mm-hmm.
willingness to change.
Yeah. Yeah. Absolutely.
I would say the same for me. I think, what was it? Year and a half ago, maybe when Cursor first released, their product didn't get unlocked until Claude 3.5 came out.
Mm.
And I think we just have to be open to, we may not be doing the same thing 3 months from now. that we're doing now.
Mm-hmm.
We may be handing them off to models, to systems, and maybe we'll be unlocked to do more and more things that we were unable to do previously. But one thing that I would kind of share with people is to be open and to try the systems out. Because I know when I tried them out, kind of had this like unlocked
Mm-hmm.
kind of inspiration that wasn't there previously because of what these models are able to do. I was like, oh, I can do so many things.
Mm-hmm.
But if you're kind of in this place where you're still kind of rejecting, adopting what these models and capabilities can do for you, maybe just take like a small subset of things that you do in your everyday life and try automating it with AI and seeing what it's able to do.
Mm-hmm.
And then if that gives you inspiration, you can kind of see what intelligence at scale does, what more and more powerful systems can do. So that's
think
kind of my parting words.
what I'd like to leave the listener is, as intelligence scales, that's not to replace anybody, but we can just set our targets higher.
Yeah, definitely. Sweet. I think that's everything. So thanks everyone for joining, and we'll be back with a new topic soon. So we'll see you guys next time.
Thanks for watching this Time Tech podcast. If you'd like to learn more about what we can offer you, please visit our website, intimetech.com, where you'll be able to see the different capabilities and technologies we could provide you in your business. Also, don't forget to subscribe and follow us to get more amazing content like this. Thanks again, and we'll see you next time.